Right. Using the free body diagram below, determine the net force. And if the mass of the block is 3.2 kilograms, what is the acceleration? So, it says F1 is 2.1 newtons, F2 is 4.2 newtons, F3 is 3.9 newtons, and F4 is 3.6 newtons. So, the net force is the vector sum of all of these. So what I need to do is find the x direction and the y direction. Now, this is positive, this is negative. So in my x direction, I have a positive, I'll do that in a little table here. I have 4.2 newtons, and I have a negative 3.6 newtons. Then in my y direction, I have a positive 2.1 newtons, because this one's up, and I have a negative 3.9 newtons. So now if I simply add these together, 4.2 minus 3.6 is a positive 0.6 newtons, and 2.1 minus 3.9 is a negative 1.8 newtons. Now what that tells me is now I have just the x direction, a positive 0.6 newtons, and in the y direction I have a negative 1.8 newtons. So the net force is the resultant of that. So to find that, I use the Pythagorean theorem. A squared plus b squared equals c squared. So c, my net force, is going to be 0.6 squared plus 1.8 squared. And I take the square root of that, is going to be my net force. So in my calculator, I do 0.6 squared plus 1.8 squared equals square root, gives me a net force of 1.9 newtons. So there's the net force. Second part of the question says, if the mass of the block is 3.2 kilograms, what is the acceleration? So now I'm going to use the net force I just found is 1.9 newtons, and the mass is 3.2 kilograms, and the question wants to know the acceleration. Well, Newton's second law tells us that F net equals mass times acceleration, so we divide both sides by mass, and the acceleration equals my net force divided by my mass. So my net force is 1.1 newtons. I'm going to divide that by 3.2 kilograms to get an acceleration of 1.1 divided by 3.2, 0.34 meters per second squared.